Hello, everyone. This is Mike Isbitsky, technical evangelist with Salt Security, and welcome to another episode of API MythBusters Chalk Talks. Today, we're going to be talking about workload protection. And before we dive in, let's arrive at a really simple definition of a workload, and that is it's the combination of the application code and the infrastructure or compute that it runs on. Right? Compute is typically the terminology used when you start talking about cloud-hosted infrastructure. Workloads can take many forms. They might be virtual machines. They can often be containers, right? When we start talking about cloud native architectures, but technically a workload could actually run on a physical appliance, right? Or bare metal in a data center. When you think about workload protection solutions, and there's a few, such as cloud security posture management or CSPM, cloud workload protection platforms or CWPP. And then there's kind of been an evolution of those two where they combine, right? Where CSPM is helpful for auditing configuration of things, such as your cloud subscription or tenant. And then the workload protection secures the workload. Ideally, those things should be combined, right? So that evolution becomes cloud native application protection or CNAPP. But they are helpful for securing infrastructure, right? And if you think about different types of infrastructure, like for instance, a web server, here, maybe this is a virtual machine, and I want to make sure it's not running a vulnerable version of Apache, for instance, right? Because if I'm running any applications or APIs on that vulnerable server, then those apps and APIs are inherently vulnerable also, right? Typically, there are infrastructure exploitable issues through the app code. The other scenario is, maybe I want to block access to that particular workload, right? Maybe that should only be accessible by internal consumers, such as an intranet application and employees within your office environment, right? So block the external access. The other scenario that's very common with workload protection is to secure Kubernetes clusters and all the workloads that run within them, because they are typically containerized or lightweight virtual machines that host containers, right? There's kind of a few runtime deployment scenarios there. But any given workload, like maybe given that this microservice that's running in a container, I want to make sure that doesn't start up using a known vulnerable container image, or I might not want to allow it to run with privileged access because that could now potentially put my other microservices or containers in an environment at risk. All right, typically in the security space, we refer to that as limiting the blast radius, right? If a microservice or container is compromised, we don't want to allow that to impact other running microservices in the environment. So certainly useful as infrastructure security solutions. The problem is, kind of when you think about user types, right? External API consumers, such as customers, right? For an e-commerce site. And then they're going to use maybe a web application or a mobile application. That scenario, right? Workload protection is not necessarily looking at application or API layer context, right? What is that consumer doing within an authenticated channel that the workload in turn powers? So if you think about the flow, right? If I am a user, I'm going to come in through my front end. I need to go through the network perimeter to get access to this given application or API. I'm likely going to come in through the API mediation points, right? Here you see kind of the outer API gateway. So your outer APIs or external APIs, that's likely going to flow in or should flow in through your inner API mediation layer. And then that would hit your microservice architecture, right? If you are kind of employing microservices. Or maybe your outer gateway just kind of redirects to a web server. That could certainly happen also, right? There's kind of a few scenarios depending how you architected the application. But securing the workload doesn't really tell me anything about what is that external consumer doing within the authenticated session for the API code that the microservice is running. Right, so we're not getting much of anything here. Potentially what you might pick up on is, if there's an exploitable API issue that allows you to inject some command, then maybe you want to execute that at the system level or file system, and then you might land and expand as an attacker, right, to access other microservices, and that's kind of addressing that limiting of the blast radius. So, workload protection might help there, but again, not addressing application layer or API layer issues.